Why is visceral fat bad? Hi, I'm David Brown from Idaho BMI. In this video, we'll talk about visceral fat. What is it? Why is it unhealthy? How does it get that way? The answers are not what you've heard before. So, visceral fat. We're all familiar with fat. It's how we store the most amount of energy. We have fat cells, adipocytes. And in our bodies, we store fuel in this form of fat, triglycerides, typically. Well, there are different compartments or areas or depots of fat in the human body. We got some subcutaneous fat under the skin. And then the other major one, another major depot or category of fat is visceral fat. And this is the fat typically identified in the abdominal cavity, around our organs, around within and around the liver, pancreas, intestines, mesentery, kidneys, visceral fat. I would add to that the organs of the chest. A lot of people don't think of organs of the chest as viscera, but they are. So lungs, heart, thymus. You find visceral fat in the chest cavity also. Well, it turns out that it is the visceral fat inside the abdominal cavity, and I would add chest cavity. It's that visceral fat that is unhealthy or that is associated with metabolic disease, inflammation, diabetes, high blood pressure, etc., fatty liver. Visceral fat, it's pretty widely recognized. It is a much less healthy type of fat than the subcutaneous fat, the fat between skin and the underlying muscle or fascia tissues. So, why the difference? Here's why. Every cell in the body has a direct connection to the brain through what I'll call circuits. Every cell can communicate to the brain through a nerve fiber and a nerve, signaling feedback information to the brain. And the brain ultimately communicates and controls, to some degree, every cell through nerves. And in this way, there's a circuit, a closed, semi-closed circuit between cell, brain, cell, and this continuous conversation between cells and the brain, tissues, organs, and the brain. This is incredibly important. When we understand this, this is going to change how we approach understanding human physiology and health. It's a very profound concept. Every tissue, every cell in the body is connected to the brain in this type of circuit. Well, the organs and the tissues of the abdominal cavity and the chest are connected to the brain primarily through nerves of the autonomic nervous system. And in the abdomen and the chest, the parasympathetic branch of the autonomic nervous system is represented by the vagus nerve. I talk a lot about the vagus nerve. Ultimately, it is the reason that visceral fat is unhealthy relative to subcutaneous fat. It's because fundamentally, people develop dysfunction of that vagus nerve, which is a very important part of the circuit for all the tissues and cells in the abdominal cavity and the chest cavity. Those tissues, those cells are controlled in part by efferent and afferent fibers of that vagus nerve. And when someone starts developing metabolic disease, fundamental to all that is disruption of the signaling capacity from the gut, the organs of the abdomen and the chest to the brain. So there's that part of the circuit that is being disrupted. And what results is imbalance. Imbalance in the autonomic nervous system, as well as imbalance between signals going from the cell and the organ to the brain, and the signals from the brain to the cell or organ. There's disruption. There's imbalance. We know this with obesity. The operations I perform, bariatric surgery, those operations work primarily by restoring the signaling mechanism, the tissues in the abdomen going into the brain. It's restoring what was very dysfunctional, and that's why bariatric surgery works. Well, It is the breakdown of that signaling mechanism in the vagus nerve that is fundamental to obesity, to diabetes, high blood pressure, abnormal cholesterol, cardiovascular disease, asthma. You can look at all of these tissues and in all these chronic diseases that are so common nowadays, fundamental to them, you see evidence of imbalance in that autonomic nervous system. And even fundamental to all that is dysfunction of vagus signaling going from gut to brain. So, ultimately, the adipocytes, the fat cells in that compartment, the abdomen and the chest, they become dysfunctional, unregulated. They become inflamed and insulin resistant. It is a universal idea, and I'm not sure why more people are not talking about it. So, hundreds of papers have been published, several in particular. How does this happen? How does this vagus signaling from the gut to the brain, how does that become dysfunctional? These are oversimplified studies, but they demonstrate an important concept. You can give someone just a lot of sugar, a very high sugar diet, very quickly, meaning within a day, 2, 3 days, that will decrease the signaling from the gut to the brain through the vagus nerve. You can do the same thing with a high fat diet, but that always has to be defined because it can be tricky in the literature. Super high fat diet will also decrease the signaling from the gut to the brain. You put those two macronutrients together, sugar, fat, it synergistically reduces the signaling through the vagus nerve. So we know at a pretty fundamental basis how we can reproduce this dysfunction of the vagus nerve. And in the brain, there's a very, very important structure called the hypothalamus. It really is the primary manager of weight, energy, homeostasis, so many things. But in the hypothalamus, there are several centers, nuclei, and all of them receive input from the gut, meaning all the organs of the abdomen and chest going up into the brain. And these centers of the brain in the hypothalamus, they integrate all this information along with other stuff, hormones, extraceptive information. They integrate it, and it's really sort of the sender of the information back to the cell. Well, studies have shown that same type of thing, give someone in the literature a high-fat diet, which really means high sugar, high fat, a non-natural food. It's a processed food that we're all eating. You change the activity in the hypothalamus. 3 major cell types in the hypothalamus, the arcuate nucleus. One is a palm C neurons, pro-opiomelanocortin cells. These are the cells that become active, and they cause the sensation of satiety. They reduce feeding. They increase metabolic rate. In opposition to them are what are called agouti-related protein neurons. These neurons, when they're active, cause hunger, food seeking, and so these two cell populations are antagonistic against each other. There's several cell types. Another one is PNOC, pro-nociceptor neurons that regulate those palm C neurons. Bottom line is, when you decrease signaling from gut to the brain through the vagus nerve, you get a shift in that balance. Palm C neurons, and responsible for satiety, they diminish in activity. The agouti-related peptide neurons are increased in activity. So someone is driven to seek food and to consume and store more food. Well, one of the pathways of communication from the hypothalamus to the visceral fat specifically is through the sympathetic nervous system, which is sort of opposite of the parasympathetic. but through the paravertebral ganglia, the sympathetic fibers going to the liver are instrumental in control of visceral fat. So, what it means ultimately when I'm suggesting hyperpalatable foods, unnatural foods, processed, engineered foods, that taste so good, Haagen-Dazs, Oreos. The presence of those foods, the consumption of those foods, decreases signaling between gut and the brain. You get that imbalance in the hypothalamic nuclei. That signals ultimately, I believe through the parasympathetic efferent, but also through sympathetic, signals to the adipocytes in the abdominal cavity and the chest cavity to expand, to grow. And so you carry that far enough. Now, the common claim is that visceral fat, the fat that's unhealthy in the abdominal cavity, it really is from spillover. In other words, a person will eat enough calories to fill their capacity of subcutaneous adipocytes, the fat under their skin. Once that becomes full, there's nowhere else to store it, and so it starts storing that fat, that energy in adipocytes in the abdominal cavity. I think that's totally wrong. It's not spillover. And think about it this way. You eat a hyperpalatable food, processed food, it's got sugar, it's got fat. Within a day, within 2 days, 3 days, you can be lean, you can be healthy. And it's all relative. In other words, compared to not eating that hyperpalatable food, you consume that food, there's going to be a relative expansion of the visceral fat in the abdominal cavity. So it's not a matter of number of calories, it's not spillover, but it's inappropriate signaling through the nerves and the hormonal system of the body on a very short-term basis that results in expansion of the visceral fat. So, very different than what we've always thought. That idea that every cell in the body is connected to the brain in a circuit, it's so important for us to become convinced of this and to recognize that this is underlying all these chronic diseases that we're bickering and arguing about. We're missing it. You can have someone with a PhD in metabolism and molecular biology. They know everything about sugar. They can tell you just about everything, how it's metabolized in the mitochondria and all this stuff. But almost never is there recognition and discussion about the role of the nervous system. And so I just want to point this out. The nervous system, the brain and the nervous system, they control essentially everything. So think I'm in Boise, Idaho right now. Say I want to send a message to a buddy in New York City. What do you think about the idea of me writing a letter and calling the Pony Express and telling the writer, okay, this person, here's the address, New York City, there you go. I'll pay you this much money. You carry this message to my buddy in New York City. Obviously, it's ridiculous in our day when we have cell phones, we have satellites, digital media. I can send a message to someone 2,000 miles away very quickly. It's the same idea. 95% of our conversations about obesity, diabetes, and metabolism, longevity, we're in the realm of talking about messages being exchanged on horses, the Pony Express program, and we're neglecting, wait a minute, we've got this system of communication in the body, the nervous system in the brain, that is controlling everything. It's connected. Something can be, a message can be transmitted from the gut to the brain in 3 microseconds. We're talking about hormones. So the visceral fat, it's not that it's necessarily causing metabolic disease. It is yet another manifestation of the root cause, which is a dysfunctional system of communication in the nervous system. It's just like people saying that obesity causes diabetes, obesity causes heart disease. No, obesity is another manifestation of the root cause. Same thing here, visceral fat. I'm not convinced it's causing all these diseases. It's another manifestation of the underlying root cause, which is dysfunction of those circuits between the viscera and the visceral fat in the brain through the vagus nerve and the sympathetic nervous system. Well, something to think about. It's always something to learn. I hope this was helpful for you to think about these things in a different way. Thank you for joining. If you like this content, punch the like button and subscribe. I'm David Brown with Idaho BMI. We'll see you next time.